Hello everyone, Mr. Minix. My name, math is my game, and today's lesson in Algebra 2, we're looking at Chapter 4, Section 7. The title is the quadratic formulae. And contrary to popular belief, you might think that the primary focus of this lesson would be on the quadratic formula. However, it's not exactly. Anyone who's taken Algebra 1 had the quadratic formula drilled into their head. And your teacher probably said, you have to memorize this. And they probably said, this is the most important thing in algebra that you'll have to memorize. It's not. Maybe in Algebra 1, but in Algebra 2, the formula, in case you're wondering where it comes from, if we start with this, ax squared plus bx plus c equals 0, what I could do to that is set it up nicely so that I could complete the square. I could say, well, we have ax squared plus bx is equal to negative c, and then I could divide everything out by an a. I'm going to divide this by a, this by a, and this by a. And what that's going to give me is x squared plus b over a x. That equals negative c over a. Now, the following steps are not necessary for you to know. You do need to know this overall process. It's probably going to be a question on a quiz. This is a standard form. This is a standard form quadratic equation. It's a standard form quadratic equation. And what I'm about to do to it is to solve it for x by using a technique that we spent all last week studying. This magical technique. I'm going to just say magic happens. Woo, magic happens. It's not really magic. Maybe you'll know what the technique is. So I'm going to add the square of half the coefficient of the linear term to this side. I'm going to add b squared over 4a squared to this side. And I got to multiply this by 4a over 4a. And so what I end up with is a times a group of x plus b over 2a squared. That's equal to b squared minus 4ac all over 4a squared. I could disregard the a. I could take the square root of this, and I take the square root of this. So I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac. Running out of room here, getting ahead of myself. This is over the square root of 4a squared. And then what we ultimately end up with, and I know I'm kind of going rip-roaring through this, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What you are responsible to know about this is that we started with standard form of a quadratic equation, and we solved for x by using a technique that we studied all last week. Anybody know the name of that technique where the magic happens? Remember the name of it? Spent all last week studying it. Completing the square. Remember that? Completing the square. Completing the square. So that's an essay question on your next quiz. Where did the quadratic formula come from? It came from taking standard form, a quadratic equation, completing the square, and solving for x. That's where it comes from. It didn't come from the Chinese. It didn't come from the ancient Romans. It didn't come from the math overlord. Somebody said, let me take the standard form quadratic equation and put it into a nice compact package. How are we doing so far? Okay? Good. Well, what's also the focus of today's lesson is this thing. Some word processors don't believe that that's a word. It's called discriminant. I'm a very particular person when it comes to spelling. On an essay question, if I let you use your notes on an essay test and you misspell something, I'm going to dock points for it. There's no excuse to misspell something if you're allowed to use your notes. The word is discriminant. And all the discriminant is it's the radicand. It's the radicand of the quadratic formula. Of the quadratic formula. Now, somebody might say to themselves, "Self, I have no idea what he just said." And they're lying. They're misspeaking. They have somewhat of an idea. They know what the quadratic formula is, but just might not know what the word radicand means. So if you don't know what radicand means, it just means the stuff under the square root. That's all it is. To be as clear as I possibly can, the discriminant then is b squared minus 4ac. The discriminant is b squared minus 4ac. That's what the primary focus of today's lesson is. So we're going to look at probably 4 examples. We'll solve a couple of them by factoring and the quadratic formula, and we'll do a compare and contrast. We'll see which one's better and why it's better. We might have to look at the graph of one of these things. Maybe we'll do 5 examples because there's one question that throws people off because they don't understand the directions. I got to be honest, I didn't understand the directions the first year I saw it. So here we go, example number 1. Example number 1, use the quadratic formula to solve 9x squared minus 6x plus 1 is equal to 0. Use the quadratic formula to solve that. So we got to identify A. It's 9. Because A is 9, we probably wouldn't want to factor this. B is negative 6. C is positive 1. Quadratic formula says x is equal to the opposite of b plus or minus the square root of whatever b is squared minus 4 times a times c. All that's over 2a. So making some substitutions, we're going to have minus 6 plus or minus the square root of minus 6 squared minus 4 times 9 times 1, and that's all over 2 times 9. So the thing I don't like about the quadratic formula is there's a lot of room for error. First of all, what's minus 6? It's going to be positive 6. A lot of people screw that up. So that's going to be positive 6 plus or minus. Another place you can screw this up is this first thing under the square root. When you square that, I didn't put parentheses for a reason. I probably should have so that I get the right thing. When I square that, regardless if it's positive or negative, it's going to end up being positive, right? So what do I get for that first part under the square root then? Negative 6 quantity squared is going to be what, 36? Right? And then the next part that people screw up is they don't know the order in which to do this stuff. They forget about PEMDAS. They don't realize that this hunk of 4, 9, and 1, that's all one big block, and all those numbers get multiplied. And you got to do that all at the same time and then subtract that from that 36. So what is 4 times 9 times 1? Is it 36? 4 times 9 is 36, times 1 is 36. So we end up with 36 minus 36. And then this is all over 2 times 9, or all over 18. Okay. How's everybody doing up to this point, okay? Cool. Well, we end up with 6 plus or minus the square root of, what happens when you subtract something from itself? What do you get? 36 minus 36, what's that going to give us? 0. Wow. I'm going to make a note on this one. My discriminant equals 0. Wonder what that's going to imply or insinuate or lead to. Then this is over 18. The fact that we have plus or minus 0, 0 is neutral. Well, if you add nothing to something, we still have the same something. So what that ends up doing is essentially wiping out this. And our answer then is 6 over 18. And we better know how to reduce that down. What's 6 over 18 end up equaling? 1/3. But quadratic equations are supposed to have two answers. So what's our other answer? And please don't say -1/3, because it's not -1/3. So what's our other answer? Anybody have any ideas? One of our answers is 1/3. What about the other one? Maybe we better look at another way of solving this. Example 1 again. Solve 9x squared minus 6x plus 1 equals 0 by factoring. By factoring. Now you're probably looking at that and you're thinking, dude, this guy's crazy. The a value is not 1. We can't factor this. And a while ago, I mentioned that if you can't recognize a perfect square trinomial, you better go sit in the back of the room and think about life for a while. Did you notice that this is a perfect square trinomial? Which factors into a binomial squared of 3x minus 1. So if you expand that out, maybe you will, maybe you won't. 3x minus 1 and 3x minus 1 equals 0. That's what it factors into. So maybe this will shed some light on what our answer is. Our answer is 1/3 and 1/3. Oh, now I get it. That's kind of weird to say the answer is 1/3 and 1/3. It reminds me of Ace Ventura, Pet Detective, when he was in Africa. What they called him, he wore his hair up in the horns, and they called him White Devil, White Devil. 1/3, 1/3. So when the discriminant is equal to 0, what we end up having happen is one unique solution. We call it one unique, that's a special word, we call it one unique solution. It's repeated. It is repeated. And what we end up having on our hands when this happens is we really have a perfect square trinomial in our midst. We're really dealing with a perfect square trinomial. I told you the focus of today's lesson isn't necessarily the quadratic formula, it's the discriminant. And there's 3 different things that can happen, one of which is when the discriminant's 0. When it's 0, we have one unique solution. That solution is repeated, and we have a perfect square trinomial in our midst. So to finish this one, the answer is 1/3 and 1/3. Okay? Do you see why Mr. Minnick's not a big fan of the quadratic formula? Can you see how much more effective and efficient factoring can be if you're good at factoring? You see why it's critical that you can factor? I hope so. I hope so. Any questions, comments, concerns, short debates, long debates before we move on? Yeah. Example 2, solve with the quadratic formula. 4x squared minus 32x minus 192 is equal to 0. I put one like this on my advanced classes quiz. And they're trying to multiply these big numbers, really big numbers. Before we move on any further, we probably ought to look at something. Here's why it's nice to have a global approach to things. Our answers to this, I don't know what the answers are just yet, but I do know it's going to be a parabola. It's going to go through the x-axis twice. I know that. I'm not going to tell you how I know that, but I know that. Because of this 4 out front, I know that the parabola that I have is going to be really tall. Because of that 4 out front. I know I'm going to have a really tall parabola. You with me so far? If I had an equivalent parabola with a 4 divided out, it would have the exact same x-intercepts. It's just not going to be as tall of a parabola. You picking up what I'm putting down here? What I'm trying to tell you is, since there's a GCF that can factor it out. Since there's a 4 that's common to every term, factoring it out is going to make this way easier to work with. Does that make sense? So if you can factor out a GCF, by all means, do it. So we're going to divide this by 4. 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 So we get 4 times the quantity of x squared minus 8x minus 192 divided by 2 is 96. Half of 96 is 48, right? So it's going to be 48. It's going to be 48. And that equals 0. So we divided out that 4, and that 4, the only thing that 4 tells us is that this parabola that we've got is going to be tall. But it's still going to have the same x-intercept. So what I'm trying to tell you is that 4 we divided out from this point forward can be disregarded. And we don't need to use it. It just shapes our parabola. But if we're getting the answers, the x-intercepts, it doesn't really matter. So now I can use a quadratic formula. X equals negative b plus or minus square root b squared minus 4ac. I still got a big number I got to multiply. Oh, man. Divided by 2a. Wow. So that's going to end up equaling minus 8 is going to be 8. Negative 8 squared is going to be 64. Kind of ran myself in a circle because earlier I divided 192 by 4 and ended up with 48. So I guess 48 times 2 is 96 times 2 is 192. So I'm right back at 192. And what ends up happening here is this. What ends up happening here is I have 2 negatives being multiplied. So that's going to be plus 64 plus 192. That's all going to be over 2. It's all going to be over 2. So I guess that's going to be 8 plus or minus the square root of 256 all over 2. Huh. So on this particular problem, my discriminant is positive. It's positive. It's positive. The last one we saw had a negative discriminant, or I'm sorry, a discriminant of 0. This one has a discriminant that's positive. I wonder what that's gonna have in store for us. Well, let's keep going with this. This is going to be 8 plus or minus, what's the square root of 256? Anybody know it? It's a perfect square, you should. It's 16 over 2. So our answers are going to be 8 minus 16 over 2, or 8 plus 16 over 2. So that's going to be negative 8 over 2. That's going to be 24 over 2. So my 2 answers to this are going to be negative 4 and positive 12. Negative 4 and positive 12. Hey, wait a minute. Those answers are integers. Because the answers were integers, does anybody know what technique we could have used to solve this equation instead? And got the answer in about 1/8 the amount of work, what technique we could have used instead of the quadratic formula? Maybe we better do this side by side. Maybe we better do this split screen. Once we had x squared minus 8x minus 48 equals 0, could we have not factored that? 48's factors that add up to 8, x minus 12, x plus 4. Could we have done that? Saved ourselves some time? Do you see why Mr. Minnick hates the quadratic formula? Hate's a very strong word. But Mr. Minnick is not a fan of the quadratic formula. It's very clunky. The quadratic formula is very clunky. It's kind of like trying to drive a motorhome in the Walmart parking lot up front by the stores, by the store. You ever do that? Probably not advisable. Quadratic formula is really not fun. When the discriminant's positive, what ends up happening this one just happens to work out nice with nice integer answers. But when the discriminant's positive, we're going to have two real answers. We're going to have two real solutions. We're going to have two real solutions when the discriminant's positive. When the discriminant's positive, we're going to have two real solutions. So I mentioned at the beginning, at the top of the hour, at the beginning of the lesson, that the focus is on the discriminant. If the discriminant is 0, there's one unique repeated solution. If the discriminant is positive, there's two real solutions. We doing okay so far? So you might be asking yourself, what else is there? The discriminant was positive. The discriminant was 0. What else could there be? A negative discriminant, and we'll look at that one next. So, example número 3. Ejemplo número 3. That's what we're going to do about 5. Example 3. Solve with the quadratic formula. 2x squared equals 6x squared minus 49. Wow. So the thing about the quadratic formula is, to use it, we got to have our equation in this standard form. Ax squared plus bx plus c equals 0. And our equation's nowhere ready to have that done to it. So I guess I'm going to have to subtract 6x squared from both sides. So that's going to leave negative 4x squared is equal to negative 49. And I'm sorry, but I got to change something. Hopefully this doesn't offend anybody. I got to make that a plus 49 here. Hopefully it doesn't offend you. Sorry if it does. I want this to work out nice. So I guess now we got to subtract 49 from both sides, right? So we'll go ahead and subtract 49 from both sides. So we end up with negative 4x squared minus 49 is equal to 0. Whoa. Kind of weird. So my a value is negative 4. My b value, what is my b value? 0 in this case. That has no implication necessarily, but it does tie into something we talked about yesterday if you were here for that lesson. And our c value is negative 49. So now here comes the big motorhome in Walmart parking lot. X equals negative b, the opposite of 0. Plus or minus the square root of b squared. That's 0 squared. Minus 4 times a, which is negative 4, times c, which is negative 49. This is all divided by 2 times negative 4. So the opposite of 0 is 0. The 0 squared is 0. And a negative times a negative times a negative is going to end up being positive or negative. A negative times a negative times a negative. It's going to be negative, right? So that's going to be minus. And this is a mess. This is why I hate the quadratic formula. Stupid quadratic formula. Why you got to be like that? 49 times 16. That's 9 times 6 is 54. Carry the 5. That's a 295. That's a 9. That's a 4. That's 5. 18. Carry the 1. That's 785. Minus 785. And then this is all over negative 8. What a mess. Ah. Wow. What a mess. So this ends up equaling the square root of negative 785 over negative 8, plus or minus the square root of negative 75 over negative 8. Has anyone ever tried on a calculator to take a square root of a negative number? Here's our third case, in case you're keeping track. Our discriminant here is negative. Our discriminant is negative. Discriminant's negative. I wonder what this is going to mean. Maybe I should take a graphing approach to this, because we can solve quadratic equations by graphing, can't we? So let me try graphing negative 4x squared minus 49 and see what that looks like when I graph it. Let me see what that looks like when I graph it. Negative 4x squared minus 49. So I'm going to go to Desmos. That's that beautiful free graphing calculator. Desmos. Maybe. There we go, Desmos. So I'm graphing negative 4x squared minus 49. And my answer is going to be wherever the graph goes through the x-axis. Does the graph go through the x-axis? It does not. So what's my answer? In Algebra 1, we would say there's no solution. In Algebra 1, we would say that there's no solution. In Algebra 2, what we say is there's no real solution. How many answers do quadratic equations have to have? 2. There are 2 solutions, but they're not real. If they're not real, then what are they? They're imaginary. Hence the need for the next section of the book on complex and imaginary numbers. Okay? So if our discriminant's negative, there's no real solution. There's no real solution. There's going to be no x-intercepts. The graph won't go through the x-axis. There's not going to be any real solutions. There are 2 solutions, and they're going to be imaginary. How we doing? All right, makes sense? I think we might be able to get this dialed in with just the 4 examples like I promised in the beginning. So, last one, here it is. Example 4. Determine the nature of the roots of g of x equals negative 2x squared plus 5x minus 4. I don't understand the words you just said. I don't believe you. I don't understand. Yeah, question. So I don't believe that somebody wouldn't understand the word I just said. Determine, that means find out, right? Roots. We talked earlier this year about roots. We talked this earlier this year about roots being synonymous with what else? There's two other words we said they're synonymous with. One of them starts with a Z. Zeros. There's another one that's a hyphenated word. The x-intercepts. The x-intercepts. And there's another word that's very distantly related, the solutions. The solutions of the related equation are also the same kind of idea. So what I'm telling you is this. Suppose we had negative 2x squared plus 5x minus 4 equals 0. We would be interested in the solutions of that equation. Because when you find the roots of a function, or the zeros of a function, or the x-intercepts of a function, it's the same thing as finding the roots of the equation. But what the heck does the word nature mean here? Does it mean go out into the woods and look at the birds? And find the snakes and the rabbits and the deer and the antelope? That's what nature means most of the time, but in the context of this problem, it says determine the nature of the roots. Remember what I said the focus of today's lesson was? The focus of today's lesson isn't necessarily the quadratic formula. It's more so the discriminant. If the discriminant is 0, then there's going to be one unique repeated solution. If the discriminant is positive, there's going to be 2 real solutions, which means the same thing as 2 real x-intercepts. If the discriminant is negative, that means there's not going to be any x-intercepts. There's going to be 2 imaginary solutions. So what the insinuation here in this context is what they're telling you but not telling you is find the discriminant, find the discriminant, find the discriminant. That's what they're telling you without telling you. They're saying, you got to find the discriminant. And you got to see which category this fits into. So what you're really called to do in this problem then is take this b squared minus 4ac business. Well, our a's negative 2, our b's 5, our c's negative 4. So we're going to take 5 squared minus 4 times negative 2 times negative 4. Some people really don't like the way I calculate these. 5 squared is 25. Remember, we have this block of these 3 numbers. Negative times a negative times a negative. That's going to make that negative, right? 4 times 2 is 8 times 4 is 32. 25 minus 32. I don't care if you can't subtract that. You know that the answer is negative, right? Negative something. Negative something. It doesn't matter what it actually equals. The fact is it's negative. What's that tell us about the nature of the roots? There's no solution, but what's it tell us about the roots? About the x-intercepts, about the zeros? Are there going to be any? No. So because the discriminant is less than 0, there are no x-intercepts. Or roots, I guess we said. There's no roots, right? Because the discriminant is negative, there are no roots. No x-intercepts. No real ones, anyway. What would have happened if we got a positive value? Then what would we have said? What if the discriminant's positive? What would we have said? That there are 2 roots, 2 real ones. What if it equaled 0? There's 1 repeated one. Got it? Well, I hope it's been educational. I hope it's been real. I hope it's been fun. I normally tell jokes. I would tell a knock-knock joke, but I don't know. I don't think you can handle it today. You ready for it? I need somebody to say who's there on tape. Anybody volunteer? Knock, knock.
Who's there?
Nobody.
Ah.
Oh, you're supposed to say nobody who.
Oh, nobody who.